Okay.
On my YouTube channel, it's Adjy Week. If you go on Twitter, hashtag DAppHack, then you can find I'm tweeting. Okay, so that's easy.
Can we start? Yep. Hello to everyone. I'm Thomas Bertani. I'm doing a presentation around Oraclize. So I guess that most of you know what Ethereum is, what Solidity is, and that we have some kind of inherent limitations in decentralized architectures, like the fact that we cannot go simply out to the internet and get some data from a smart contract, because it's not easy to find the consensus on some kind of off-chain data straight from some Solidity code or the Ethereum virtual machine itself. So Oraclize is a project backed by 6 people at the moment, and it's 1.5 years that we are trying to solve this very issue. So we are not integrated with Ethereum only, but with few blockchain, even if I would say 90% of the service usage is on Ethereum itself. So I will start with the presentation. So yeah, there is no need, I guess, to talk about the blockchain overhype. So there are a few use cases that help a lot to understand why we need data in blockchain applications, in Ethereum applications. So this is just one implementation for the flight delay insurance. I'm referring to the term one implementation because there are like 4 different implementations of this exact project that were done in the last 10 or 12 months. So it's something that people like to do, essentially because it's very easy. And it's one of the most obvious applications to implement on Ethereum, right? So the idea is that you have a smart contract which can provide some kind of flight delay policy, insurance policy, so that instead of going to the website or to a service from the insurance company, you just interact somehow with a smart contract, you get your insurance, and the smart contract keeps monitoring the flight status and does release the payment according to whatever happens to the flight. So it can either be peer-to-peer, like in the insured case, or it can be partially centralized, like FTD. So this is kind of production ready, so you can go to this website. This is not something that we did. It's some German guys. I don't see them here, but I'm sure that some of you know them pretty well. So those German developers were the ones doing the last public implementation that I'm aware of, at least, for the flight delay insurance app. And this is very easy to use. So they presented it at DevCon 2 in Shanghai a few months ago. And yeah, I think the usability has now reached a point where pretty much anybody who can install an Ethereum node can interact with something like this. So yeah. Another application that is very interesting to me is cash on delivery. Well, it's interesting to me because I've discovered just in the last few months that cash on delivery is an issue in Italy only. So as you can easily guess from my accent, I'm Italian. And in Italy, we have still like 40% of all shipments which are paid with cash on delivery. So people do actually pay the carrier when he gives you, the parcel at the doorstep. So it's still pretty weird because, the Italians are not really familiar with electronic payments and blah, blah. So they still like paying by cash. And there is a huge cash handling fees involved. So you have usually at least 10 euros extra fee just to cover for this cash handling issue. And the point here is not really just e-payments, but is even the fact that in some countries, people are not really familiar with, buying stuff online and this kind of stuff. So what happens is that they don't really trust the merchant to send the parcel, and they would prefer to have some kind of guarantee. So this guarantee could be the cash on delivery, or could be like a smart contract monitoring the shipment, so that instead of paying the merchant, you pay, as a buyer, you pay in advance to a smart contract, and the smart contract can monitor the parcel and implement the same logic that you have on cash on delivery. So you pay just when the parcel is in your hands, but you can automate it, and you can give some strong guarantees even to the merchant. Because today with cash on delivery, the merchant has no guarantee that the buyer will ever pay, because he is not paying in advance, right? So this is yet another example. So I guess most of you are developers. Myself, I spend at least, I think, 1 hour per day on Stack Exchange just to look, for help from other developers on common issues. The point, especially in the Ethereum context, is that there are not that many knowledgeable developers yet. So it's really hard to find good informations, and usually it takes time to find somebody who actually knows the answer for some specific very weird or niche issues. So there is no incentive other than the reputation in the community. So this is yet another smart contract. It's the Stack Exchange Bounty contract, which tries to address this issue. And what it does is similar to ChangeDeep, but instead of rewarding somebody afterwards for some content, you put some bounty in advance in the smart contract, and you link it to the answering of a specific question. So anybody can post a question on Stack Exchange, and anybody else can just go out there and use this website, this Stack Exchange Bounty contract, and put some money, put some ethers via the smart contract on the answering of this given question. So in this case, the smart contract just keeps monitoring via the Stack Exchange APIs the status of the question, and if there is any correct answer, then the funds are automatically released to the Stack Exchange user. So it's pretty complex. I don't want to go into details now on how the smart contract can understand what is the Ethereum address of the Stack Exchange user, or what are the security implications, and blah, blah. I just want to throw to you some random examples and to look for some features, something that they have in common. So these three examples are essentially inherently peer-to-peer. So they are putting in touch two different sets of people. So we have on one side the pool of people willing to buy a flight delay insurance. And on the other side, with the peer-to-peer insurance model, we have people willing to put some money in the smart contract to have the policy engine to run, right? And they want to make some money. Or we have people, or the buyers, which want to interact with many different merchants. Or we have on Stack Exchange, we have random people posting questions and random people which could potentially answer or put money, right? So there is no, by design, I mean, in all these examples, there is not really a central party, let's say, or there is no real need for a central party, let's say. And in all these cases, there is some kind of action which triggers a payment. So there is always a payment involved. So this is why it's a good fit for smart contracts, and I guess I shouldn't spend much time on this with you guys, because I expect you to already be familiar with this. So these are some random piece of code, pretty old. I guess they are not following good practices anymore. But they are all referring somehow to data. So you see here, for example, that we have a Solidity smart contract which wants to check the status of the question via the Stack Exchange APIs. Or we have the flight status which is being checked via Wolfram Alpha, etc. So in all these cases, if we get rid of the other intermediaries, we end up noticing that data is the only escrow left. So essentially, the data itself is choosing where the money goes. Because if the data coming from, let's say, the Stack Exchange API or the flight status data source is wrong, then we will, of course, trigger some wrong payment, right? So data, the data source, the place where data is coming from, is choosing whatever happens, right? Because there is no other intermediary. Providing data to the blockchain is usually what the Oracle does, but I want to start with some definitions, because there are 5 or 6 different definitions of oracles, and they are keeping to increase over time. So these are the definitions that we use. It could be that, you know, you don't agree with those definitions, but these are the ones that we choose to use for consistency reasons. So to us, the oracle is just the party in charge of connecting the smart contract with the data source. The data source is the party creating the data or distributing the data. And then the query is just a formula defining whatever data you want. So you, let's make an example. You could have as data source Wolfram Alpha, as formula what's the temperature in Berlin, and as oracle somebody, any of you, which checks the data on Wolfram Alpha and sends it to the blockchain. Okay. Of course, the data source can be, I don't know, the internet. The query can be an API call, or yeah, it depends on how far you want to go and what's the abstraction that you want to use with these definitions. It wasn't defined. It's not included per se in the definitions themselves. So Oraclize is just one oracle, essentially. And what we try to do is providing, in an automated way, the connection between any data source, potentially any data source, and any smart contract or any blockchain application. So we are an intermediary. We are the bad guys, which can break the old security model of Ethereum, right? So this doesn't make any sense, of course, because if you have an oracle which intermediates between the data source and the application, then it's not the data being that is the escrow anymore, but it's the oracle itself, because the oracle could claim whatever it wants, right? So if the smart contract comes to me to ask what's the temperature in Berlin according to Wolfram Alpha, I could check on Wolfram Alpha and report this to the smart contract, or just say something else. The smart contract has no way to verify it on its own because of the limitations that I was referring to at the very beginning of the presentation. So what Oraclize wants to do is to address this very issue by providing some kind of evidence, which could be used to verify that the oracle didn't tamper with the data. So it's as easy as that. So we just want to show, to be able to answer to any question, to bridge data, let's say, from any data source and smart contracts, while showing that the data that we're carrying has not been tampered. So this is exactly what this chart should somehow show. So the idea is that in most use cases, you want to go to web APIs. So think about a common need, which is, I don't know, looking for a price feed. You want to know what's the price of 1 Ether in dollars. So there are many ways the smart contract could get this data, right? Of course, I mean, you could potentially go and ask data to Augur or to Gnosis or to some other prediction market. Or you can just have some centralized piece of code, which is maybe 5 or 10 lines of code, to get the data from the data source and push the price as a claim coming from you to the smart contract. So there are many different ways you can provide the data to the smart contract, but those are not really, on one side, proven to be safe, or they are not verifiable by a third party. So the third party should just accept that this claim is coming from there with no way to verify it by itself. So even with the prediction market, it is a bit more complex because with the price feed, it could be easy. But with other informations, it really depends, like you have to check if there is a proper market, if a prediction market do actually have an accurate information. So let's make a concrete example. Let's think about the US elections. All prediction markets were wrong, and nobody did really see that Trump would be, the winning one. So prediction markets, in theory, are very interesting and very good data sources, but it will take time, and you need to have really a huge amount of people interacting with the system in order for the information in the smart contract to be accurate. But anyway, I don't want to speak about prediction markets, even if it's very interesting, because I think that the use case that we want to address here is different. So the need that we are trying to solve here is just to provide the data immediately, straight away, for any data, for any. So of course, we cannot just go to a prediction market and ask for the altitude of a given flight. Who cares? I mean, there will never be as many markets as all the flights. So Oraclize tries to address this issue and to provide some kind of standard API on Ethereum. So let's just stick with Ethereum for simplicity reasons. So this is a simple Ethereum contract in Solidity, and you see that the way you get the data is simply via function call, which is implemented in an external Solidity file that you need to import. So you just import this Solidity file, and you specify the API call you want to make. So here we are calling crypto compare APIs. You can specify an optional delay, so you can have like a smart contract which is kind of independent in the sense that it could potentially check once per hour what's the price of 1 Ether in US dollars and just do something accordingly. So for example, here we see that when we create the contract, we just check the price straight away. It's asynchronous, so we need to wait for Oraclize to send the transaction back. So Oraclize sends the transaction back calling the callback method. And in the callback method, you implement whatever logic you want. So here we are just storing the price we get back in the storage of the contract. So we are not really doing anything useful. But we could potentially, as you can see here on line 18, which is commented out here, that we could potentially call a query again in 60 seconds. So we can have a system which is independent after the deployment, as long as there are enough funds to cover for the fees and blah, blah. And so as for the fees, Oraclize is taking 2 fees. So one fee is the service fee, which we have designed in a way it's usually way lower than what you end up paying to miners for including the transaction. And on the other side, you need to cover for the callback transaction fee, because we are the ones which need to send back the transaction to your contract. So Depending on how much gas you want us to send to specify in the callback transaction, you need to pay a different fee, which is being used to cover for it. So Oraclize can abstract data sources, so you can choose a data source. Most of the times it's URL. URL just means that you want to do a HTTP GET or POST request. But you can choose different data sources. So for example, you can get some content via PFS, and I hope even via Swarm very soon, or from any other data source. So it can be Wolfram Alpha, it could be, well, there are many others, but I don't want to go into details now. The authenticity proof is the interesting part here. So in the last year, we have sent 1.5% of all Ethereum transactions ever on the mainnet and testnet. So like 0.5% of all transactions on the mainnet and 4% of all the transactions on more than. So there are real contracts using it. And authenticity proofs are the only reason why Oraclize could make any money. Because of course, you know, this system can be implemented by anybody with little to no effort. But the difference is on the architecture side, because generating these authenticity proofs, so these cryptographic proofs which can prove that we didn't tamper with the data, comes at a cost, even to us. And actually, we are not really making any money because the price that you end up paying to the service is pretty much the price to run the infrastructure. So the idea is that these honesty proofs are stored somewhere in a permanent way, and you can use it at any time to verify even for the past that the transaction were really you know, feeded with real data, with data which was not tampered with. I don't want to go into details too much unless there are questions. So we are using different technologies to provide these authenticity proofs. So some people think that Oraclize is just using TLS notary. So some people think that Oraclize is TLS notary or something like that. So usually people complain about the security of Oraclize because they think TLS notary is broken. Most of the time I see that they didn't really understand TLS notary, but I could, well, you know, TLS notary itself is an external project. It's not even really, it's not something that we did. It's an external project that is very interesting. It was created for a completely different use case. And there is a very interesting white paper on tlsnotary.org. The idea is that Oraclize provides authenticity proof, not TLS notary proofs. So we can provide different kind of proofs. And we are already providing another one that we built in-house, which is based on a different technologies. And it's based on some trusted execution environments techniques. So the idea is that we use whatever technologies make sense to use. So whatever technology could be leveraged to create these honesty proofs and prove to third party that we are behaving honestly. So we are using Intel SGX as well, but we don't have any public service leveraging the technology at the moment. We are creating a random data source for this. So the idea is that we can generate a random number in a trusted environment. Trusted means that we can prove to anybody that the random number is coming from a low-level Intel CPU-backed random instruction, which is, how can I explain it? Essentially, Intel is putting a signature on the fact that we didn't tamper the code executing the random instruction. This is pretty much it. Of course, you need to trust Intel. So there is always some trust involved, and the only way you can get rid of all trust lines is pretty much with a blockchain. But what a blockchain does is finding the agreement on the timestamp, which is cool, but getting off-chain data in a reliable way is much more complex than that. And for for generating random numbers, so having good sources of randomness, I'm confident that at some point there will be some meaningful way to generate it on chain, but we are not at this point yet. There are some ways which are kind of safe, but it always depends on how much you're putting at stake, of course. So maybe with 10 euros is fine, but yeah, it really depends on how much you're putting at stake in the smart contract side. So we are essentially providing an attestation as a service thing. So the idea is that we use different external technologies like TLS Notary, which needs you somehow to trust Amazon, or the Android proof, which needs you to trust Qualcomm and Google to generate this authenticity proof. The idea is that you don't need to trust Oraclize. You still need to trust those attestators. Those attestators are not anonymous. And the idea is that our assumption is that if you get this data with authenticity proof and different proofs coming from different technologies, you have something which is much stronger than having just the agreement, I don't know, between 8 random anonymous people in a set of 10 oracles which are acting on a voluntary basis. So of course, this is just an assumption. But yeah. So if some of you want to play around with this thing in the weekend, there is something new that we have been working on during the last 6 months, which is a way to extend this concept of data gathering to computation. So you can essentially write a piece of code, delegate the code execution to us, and we can prove that a given result is really coming from that code with no alteration. So this can be used for different things. So you can like overcome EVM constraints. So just to make a simple example, there is no way today, there will be one hopefully in a few months, but at the moment you cannot do the verification of RSA signatures on Ethereum. You can easily do that with something like this. Or there are some operations which are very inefficient on Ethereum. So we needed at some point to execute a SHA-1 to compute a checksum. And we just opened 2 days ago an Ethereum improvement proposal. But it's just not viable because it will cost millions of gas just to execute it on a few bytes. And it's very efficient. It's optimized with many parts in assembly code and blah, blah. So the idea is that if you don't have a EVM instruction or a precompile which can provide this at a low cost, then it's simply not viable on Ethereum most of the times. So you can execute it off-chain in this way. I don't go into details because it's pretty complex, but I can share the paper if some of you are interested. And the way you interact with it is you just write the code in whatever language you want. You define the context via a Docker container. You create a zip archive. You put it on IPFS. And you just give to us the IPFS multi-hash. We then compute it and prove to you that the code is really coming from there with no alterations. So of course the interesting part is how we can prove it, but it's very complex. The idea is that we have a virtual machine that we start, but we cannot modify afterwards. And if you do trust the attestator again, which is Amazon in this case, then the execution was really safe and was not compromised. So if somebody is working at Amazon, of course they could compromise the result of the computation. And this is why we are trying to lower this level of trust in some ways by using different providers. But still, you don't need to trust us. And of course, I guess it's easier to trust Amazon than a small startup. So it's a compromise, of course. It's not perfect. But I think that perfection is not really something that is useful in real production services that we have today. So it's always about finding a good balance. So if you have any questions, feel free to ask. I will be around even during the weekend. I'm looking forward to play with some contracts and write some interesting stuff. So even if you want me to join some of your teams, I'm very keen to do that. And thank you. One last thing. I know that many developers are used to use different frameworks, test RPC, etc. during the development process. You can use and test Oraclize from there. You just need to go to GitHub, to our GitHub, and look for the Ethereum bridge tool. It's very easy to use, and it provides a connection between any Ethereum chain and our engine. If you want to just test it in memory, you can go to dapps.oraclize.it/browser solidity, and there is a modified browser solidity version in which you have the integration with Oraclize. So you can easily test Oraclize contracts, and you can execute them in memory. So it's pretty handy for the development itself. And a good place where to start is dev.oraclize.it, where you can find the documentation. And by clicking here on the first one, there is the link to the modified browser solidity with few default examples, which you can just try straight away from your browser. The documentation is quite a mess. So if you have some questions around something which is not explained in documentation, just feel free to ask. We have like 20% of the features documented. So if you want to do something which is not in documentation, just try asking, and maybe it's already doable somehow. Any question?
Is there a way to prove the timestamp of the data? Because when you have a price feed, it would be quite interesting to have not only prove that the data source is not tampered with, but also the time.
Well,
Can you repeat the question for the video?
yeah, of course. So he's asking if there is any way to prove the timestamp for the data. So the authenticity proof by itself has not even nothing to do with the blockchain, because you can generate an authenticity proof for a web content even just from the website, right? So if you go there, for example, you can just test queries and generate a proof with no blockchain. So the proof is just a piece of data, right? Some cryptographic piece of data. It's not just a signature, it's much more. But so unfortunately, unless you use the blockchain, there is no technology which can prove the timestamp. So this is all the blockchain is doing. So of course, if you want to check the time, you can ask to the given web service. You can ask to an NTP server. You can ask to Google, but the blockchain is the only reliable source. So every time, in the honesty proof, you have the time which is claimed by the server of the, which is providing the data. So let's say that you get the data from an exchange. There is a reference to the data coming from that server. Of course, it might not be reliable, but this authenticity proof is not saying anything around the quality of the data. It's just saying that the data is really coming from that data source with no alterations. So in the case of price feeds, it's a good idea to make, aggregations from different data sources. Yeah. Thank you.